This conference will now be recorded.
Okay, so last session we learned about how do we take heap dumps and actually what is a heap dump, what all kinds of information it includes, and what are the different methods we can do. We can take a heap dump of different types of applications and different environment. So most common ways of taking heap dump, we saw that using command line there are three commands. There is jmap is a common command, and there are also few of the other tools which will help us to take heap dump. Okay, now in today's session we are going to see that once we take the heap dump, how do we actually proceed with the analysis. So what actually we should look for the clues in the heap dump, and how should we proceed further. Okay, so now we will for today's session we will target two ways. So one is using tools that that nowadays are available, easily available tools, and other option is that I'll also show using command line, because in most of the organizations or most of the companies you may not be allowed to use freewares, or you may not be allowed to use the open source tools. So in that case, using the existing tools or existing tools that are available within the JDK, how do we can analyze the heat. Okay, so we will look at those two things. Okay, so for this, uh, I have already started our sample application, that is the JPit store, and now it is running. So I have also opened JVisual VM. If the screen is visible to you, which I hope should. So you can see that this Tomcat PID is there, 27296, and this JPEG store application is running. So you can clearly see at the right side heap graph. So a heap memory is progressing, and the GC at particular interval is happening. So the application is in running state, and it's already, it just started before 1 or 2 minutes. So we will let it run for some time. Meanwhile, I can show you that how we are going to take the heat. Okay, so now as we have already opened the JVisual VM, so in JVisual VM you can take heat dumps, by in two ways. Right now you can see this is the left side, where you can see all the applications listed. You just right click the application you desire, and you see the options over there, right? Thread dump, heap dump, and snapshot. So you just click on the heap dump, and you will get the heap dump of that at for that moment of the application. Otherwise, you go to this monitor tab in the, you open this PID or open the process that you want to monitor of your application. You open, once it's open like this. Now that I opened this Tomcat PID, and just go to the monitor tab. In the monitor tab, you can see the heap memory monitoring is there. So you are seeing this graphs. Just above the graph, you can see two options. One is perform GC and heap dump. So this way you can also take the heap dump over here. If you just click the heap dump, it will again capture the heap. It will dump the heap of the application at the moment. Okay, so now let's just take a heap dump. You're using one of the methods. So I'll just right click on the PID, and I'll click the heap dump. So now you can see within an instant it got generated. So you can see that heap dump in the same window. It will just open a new tab, and it will give you the total summary of what has been captured. Okay, so now we will just go through it, and we will see that how we can analyze it through JVisual. So though in JVisual there are not so many options available, or it is not that much user friendly for first time heap dump analysis, or whoever is analyzing the heap dump, or who is trying to look at the heap dump at very first. So it is not that much information available, but it at least include the information which is required for you to analyze the heap dump, right? So you can see that I've already opened this heap dump. So there are four tabs as of now. So it's summary, your classes, your instances, and this is OQL console. OQL is nothing but object query language. So similar to SQL, we have a query language for querying the objects. So this is useful in the heap dumps because if a particular object has been suspected, so you can actually look for that object in entire heap dump, and you can trace that object in which class is generated this object, or in which method this object is getting generated. Likewise. So now we'll just go to the summary part. So in summary, you can see that the very first part is the basic information. You can which includes when the heap dump has been taken, where is the heap dump file, what is the size of your heap dump, and inside the heap dump, what are the total classes available, what are the total number of instances and class loaders, what are the GC routes, and total number of objects pending for finalization. Okay, so GC routes is a very important thing when we are dealing with heap dump. Okay, so GC route is the route of GC which are accessible outside of the heap. Okay, so this is the point which is accessible outside the heap. So that's why that's how the GC works. Okay, so it will first collect the GC routes, and it will mark the live objects, and whatever the live objects it has marked, it will spare those objects, and rest of the objects it will consider as a dead, and all the objects will be swiped or swept from the memory. Okay, so this is how our GC work that we already discussed. The next part in your summary is your environment. So on which machine or which whatever JVM hosted on which machine, and what Java vendor you are using, what is the Java version, all this basic information. Okay, then we have system properties and thread dumps. Okay, so this is something new, that threads at the heap dump. So since JDK 8 above, they have started giving this facility. So whenever you take a heap dump, at the same time it will also take a thread dump. Okay, so it is a complementary for your analysis, because most of the time we can it is observe that the objects in heap they are actually related to the particular thread running at that time. So it is also important to analyze the thread dump at the same snapshot, or at the same time whenever you are taking a heap dump. Okay, so you can correlate your analysis efficiently. Okay, so just if you just click on this.
Yes, Shita. Can I ask a question, please?
Yes, yes.
So if we take the heap dump, it's like we are taking thread dump while taking heap dump, right?
There is very much disturbance from your side.
Okay, go ahead. Okay, keep on. Just go ahead.
Okay.
Yeah.
So whatever your question is, and you can just type in once if you are able to join through the laptop, or in the chat you can ping the question. You can access the chat over phone.
Yeah, I'm on phone. I can't join using the laptop. No internet connection. Yeah.
Okay, no issues. So what was your question? Now it's clear. Your voice is clear now.
So I was asking, during heap dump is like we are taking thread dump, but what about during thread dump? Is it okay? We'll be taking heap dump also. The reverse work, or it doesn't work?
No, it's not the reverse. So when you take a thread dump, it is specifically thread dumps are taken within a regular intervals. So thread dumps is like say within a 10 milliseconds span, or 5 to 10 most of the time 1 or 5 seconds span you take a thread dump. But for heap dump, because heap dump is very what we can say, it's costly for the JVM, because whenever a heap dump is triggered, first thing is going to be done is entire GC, the full GC will occur whenever you trigger a heap dump. Okay, so the reason behind that is so the JVM doesn't want to include all the objects that are been already finalized, or that are been already garbage collected, or marked for garbage collected. So all these objects will be get stripped with a GC, and then your heap will be dumped. Why the thread dump is coming with heap dump is because JVM wants us to show that these are the threads which were running when you took the heap dump. So it may help you to analyze further, and it may help you to process. No, if your CPU is going high or something, some issues you can correlate with that heap dump. But the reverse is not true. Whenever you take a thread dump, it will always not trigger a heap dump. But heap dump will trigger a thread dump for sure. Okay.
All right. Thank you. Thank you.
Okay, so now I'll just click on threads so I can we can see the thread dump also here. I'll just click on threads. So it is all giving you in the same window. So you can see the threads at the heap dump. The title says the same thing, threads at the heap dump. So whenever when you took this heap dump, what are the threads running, and you know what was the status of the threads, what objects they have locked in. So all this information you can see over here, and we already saw that how do we read a thread thread dump, right? So you can see most of the threads in waiting state, one few in runnable state. Sorry, sorry. Okay, so this is how you get your thread dump. Now let's move to the actual part, analyzing our heap dump. Okay, so now we have this heap available over here. Now you can see there are at the right side of the plane, or at right side of the window, you can see there is one uh, box which is showing inspect, and it is showing the biggest object. So we have it is by default they are giving find 20 biggest object by retained size. Okay, so this is the general phenomenon of heap dump analysis. So what is actually looked for in heap dump analysis is which are the objects, or which are the classes, which of the instances are actually consuming more size. So why it is that? Because we need to understand the purpose of taking a heap dump. So when we take a heap dump, that previous to that we suspect that there are some memory issues with the application. Either application may be leaking a memory, that may be, that may be a conclusion of observing the runtime memory graphs, and it is not collecting, the GC is not able to collect entire memory. That's mean we can conclude that it is having a memory leak. So now to find out the memory leak, we take a heap dump. Then there are multiple reasons, like application is not sustaining properly, or there are multiple restarts are happening, and memory utilization is not proper. Memory is getting filled up very soon, right? So there are multiple reasons we take a heap dump too, right? So all this starts with the analysis starts with the common thing, that is to find out the biggest objects, or biggest space taking instances or classes. So that's why we have the this rightly available over here. So find 20 biggest object by retain size. If you just click find, it will do a query. You can say that retain size will be computed. So there are two different sizes. Okay, I will show that once we open this in the mat analyzer. So now when I just click on yes, it will open the you can say this is computing the retain sizes, and it will open another window, and it will in another tab. It will list all the objects which are 20 objects which are biggest in the size inside this heap dump. So let it compute. So what is a retained size is like, uh, there are two different sizes. When you say a heap dump, you will see two sizes. One is the shallow size, and other is the retain. So shallow size is nothing but the maximum space which is required for your object, like it is a character, it 8 bytes integer, your 8 byte integer array, right? And retain size is what, whenever you take a heap dump, so retain size is how many objects, or how many uh, this classes or instances or objects are created for with this particular under this particular class. So retain will actually give you the size which can be reclaimed if these objects are cleared out of the memory. If GC swipe out these objects, this will be the retain size that can be reclaimed in the heap. So that size it will show. So now that's why it is computing the retain size. That means it is actually trying to calculate how many objects are with this size is available, right? So if these objects are freed from the memory, how much memory can be retained, like that. Because so it's still computing the retain sizes. So till it is doing that, we'll just try to move to the next tab, and we'll just try to discuss what's there inside this. Okay, so next tab, you can see the list of classes present inside the heap dump. So once I click on this classes, it is already sorted in the downward direction. So number of instances consuming most memory is always on the top, and in the same way, you can see that in this window, you can see this character class instances. So percentage of instances, it is no, it is already sorted from down to high to low. So maximum instances of character classes can be seen. So there are total 68,167 instances of this character class. So this is the native classes of Java, right? So the problem with this JVisual is that we will not be able to actually get inside the things. It will show us the this kind of things only. So character class, concurrent heap have. So we will not be able to actually analyze that what is the problem, or we need to dig down further to check what is the problem. Okay, so you can see instances sizes there. So for the character class, for all these instances, 20% of the instances inside the heap are for the character class, and they are consuming out of 38% size. Okay, so how do you find out the objects inside it? You just right click it and show in instances view, or show only subclasses. So this you can see once you right click in show instances, we already have that instances. In the same way that we in the mat, we see the objects inside that instance. Okay, so now if you see in the instances view, now we can see all the character instances, all the instances that have been listed for this class. 68,167, all these instances will be listed over here. So first 500 will be listed first. If you want to dig down further, then you can scroll it down, but you know that deep level analysis is not required. So in this particular window, you can see that particular instance and what are the character values that have been hold inside the instance. Okay, so for example, if I just click this first instance, you can see there is some 0:00. There is some kind of character value. So you can see there is this character value is including the gate command. Okay, gate jpit store actions catalog dot actions session id. So this is entire thing is included in this particular instance. So this is nothing but the log. Okay, so the tomcat log that has been logged, it is actually inside the heap. Okay, so it is taking whenever you are taking a heap dump, it is logging it. So these things are there. At the bottom side, you can see total array type, object type, and primitive type. It is there are the attributes or legends, you can say. So it is already described. Square bracket means it's array type. A red dot is your object type. So what is the object type? Is character buffer, CB, right? And you can see this there are the different types of legends described over there: gc, root, and loop. If there is any kind of loop, you can also see that inside the references tab. Okay, so now as we discuss about the retain size. So here you can see there is also an option compute retain size, but it is not available at the instances level. Okay, you can compute it at the very high level, and it will start calculating the references and collecting all these things. Okay, so I think this computing is still not completed. Let me just restart it. It got hung for some reason. I don't know.
So this heap dump analysis is only applicable in Java application, right? Not any other application.
So whatever applications are using JVM, you can do the heap dump analysis. So we already discussed the different types of heap dumps, right? There are some portable heap dumps for our IBM application. There are some HPROF and binary dumps for another application. So whichever application is running on JVM, it will we can take a heap dump.
Okay. Okay.
Okay, so just move to the instances tab. Now this is the basic information now we see, and how do we analyze, or how do we cater the segregate this information. That now we are seeing that. Okay, there is one more option, or just going to the classes tab, you can see this compare with another heap dump option is available. Okay, so we have discussed this kind of scenario when we need to do compare this heap dump. So whenever we are observing that there is an application is generating a memory leak, or it's causing memory leak, at that time we will advise to have three different heap dumps, right? One just after the application is start and it's normal, nothing is going on to the application, it's in an idle situation. At that time we take a heap dump. Another heap dump we take when application is running. Okay, so now users are accessing the application, and it is under the normal load. Okay, and the third heap dump it will take, or it will automatically be taken by the application when the out of memory error occurs, right? So these three heap dumps, when we have these three dumps, we can use this compare with another heap dump option over here to just to find out which are the objects and which are the classes are there in the heap dump which are required to run the application normally, and which are the classes which are actually containing or holding the sizes, heap size, and leaking the memory, right? So this is the for the detailed analysis of memory leak. If you are not able to find out within the out of memory generated heap dump, we can use this kind of uh, method for analyzing this. Okay, so now let's just move to the another tool that we will be using is mat. Okay, so mat analyzer, I already downloaded the setup, and I will show you how you can open the heap dump. So before that, we will just save this heap dump, and I will show you that how do you just right click on the heap dump in this applications tab, click on save as. Okay, it will ask you for where you want to save it, so we'll just give one path. Okay, so it is heap dump. After the heap dump, it automatically puts the date time stamp. We'll just make it more readable, 31st July. Okay, so I've just saved this heap dump. Okay, now we will open one now we'll open the tool mat analyzer. Where it is. Memory analyzer. There is a jar file for this mat. I have downloaded it. I am not able to see where it is. Okay, let's do not waste any time. We can download it fresh.
Section is recorded, right?
Yeah, it's getting recorded. Okay, so you can see here the link is this Windows x86-64 that we want to download. Okay, so it's getting downloaded. I already had it downloaded. I don't know if I misplaced the setup somewhere or okay. So till it's getting downloaded, I can also show you that the second part that we would be doing, right? Using a online tool, that is Heap Hero. So before that, let's take another heap dump so that we can compare it with the previous heap dump. I'll just click on the heap dump again in the JVM. Sorry, JVisual VM. Okay, and we'll also save this heap dump as in the same path. Okay. Okay, so meanwhile it got downloaded. So let's just open it quickly. Okay, you can see this mat is and one application is automatically you can see this. So you just have to extract it. Who have the source code of the Heapdump of the application. Okay, so now you can see that this memory analyzer window has been opened, and at the very front page you can see there are different types of options available. So how to get a heap dump? If you click over here, you will get the entire commands take a heap dump and all the things that we already discussed. Okay, so we are interested in opening a heap dump. You can see this workspace, open a heap dump. Okay, so I just click over here, open a heap dump, navigate to the path that we have saved the heap dump. Okay, so I want to open this one first. Just click on open. Now it is passing the heapdump file, and it will show the same kind of information, but the additional benefit of this using this tool, you can say this, there is one window now which is saying getting started wizard. In this, it is automatically showing you the three possible ways you can analyze this heapdump. Okay, so there are the three possible what we can say objectives for this, or analyzing this heapdump. First is your leak suspects report. So it will automatically check your heapdump for any memory leaks and the suspects of any leak. if the objects are being leaked, right? Other second is your component report. To set, it will analyze the number of objects in your memory, which is which may have issues, memory related issues, like some of the duplicate strings or empty collections, finalizers, weak references, etc., right? And the last one is your uh, last option is just reopen the previous year reports. Okay, so this option is also available once you take a heap dump. Okay, I'll also show that how where you can access the same wizard. Okay, so as of now we will just start with the by default setting leak suspect report, and I'll just click the finish. So once I click the finish button, you can see at the right side of the bottom it started generating one list report. So you can see this, it's already generated this report, leak suspect report. Okay. So how do we read it? Just let me just adjust the windows so you will be able to see it properly. So before going to this report, use this overview tab. In the overview tab, you will have the same information that we had in the JVisual VM summary tab. Okay, so all this information, right? What is the when we have this taken, what is the size and everything. But the advantage of MAT is that you get a graphical representation of everything, right? You can see this, the total size of your heap, and how it is distributed amongst the objects. So if you just hover at any one of them, you see at the left side different types of attributes are there. Left side of the mat analyzer is your inspector. It will give you the details of that particular area, right? And same way, you can see these objects are biggest objects by retain size. They are segregated in a pie chart format, right? You can see this circle, and total is 21.5 MB that can be that these objects are retained, and 16 MB of these objects have been marked white, and the rest of the objects are have and the different colors are given. Okay, so as you scroll it down in the overview tab, you can see there are reports section, and here you can access the same thing. The report that we already included first, we already generated the leak suspects report. After that, we have the top components report. Okay, this same window can be accessed from here. Okay, and the last was your component report, which will actually analyze all the objects which belongs to the common root package or common class loaders. Okay, now at the left side also you have different actions available on this heap dump. First is your histogram, then your dominator tree, then top consumers and duplicate classes, right? So this actually gives you a lot of control or lot of insights of your heap memory analyzer tool. So if I just click on this histogram, it will list me the entire classes, objects, and shallow and retain size. Okay, now this is the thing that we were discussing before. Objects, shallow heap size, and retain heap size. Okay, so you can see this character string again over here, which is having highest number of objects in the heap, and the numeric value of shallow heap size is somewhere around 10 GB. Oh, sorry, 10 MB, and the retain heap size will be is approximately same. Okay, so this is how we actually get the total number of classes. Now if you just right click on this class, and you can see there is the option list object with outgoing references. Okay, so whenever you are analyzing this heap dump, you just want to check the top contributor or top consuming classes, and just click on this read with outgoing references. So list objects with outgoing references, so it will list the objects which has a reference to another objects, right? So in this way you can analyze this heap dump, and you can go deep down inside, and you can check which are the objects which is causing more heap memory. You just click this expand this bar, you can see over here. So there is no other objects inside this now. That is the final character objects. Okay, so in the similar fashion, we can identify the objects which are actually using a lot of space in the memory, using the histogram. Okay, now just move to the leak suspect report. So this mat analyzer will automatically analyze the heap memory, and it will give you some suspicions, right? So it is not necessarily true always. Okay, so it is up to you for you to analyze it and understand the fact that the leak suspect will always give you some suspect. So what it is doing actually, it is actually trying to get the classes and the objects which are consuming high memory. It will automatically list this, and it will treat them as a suspect. So now you can see it has given two leak suspects. So one is with 2.2 MB and another is with 6 MB, and there is one more is this C remainder. Okay, so we can try to understand what suspect it is showing us. So you can see the class loader component, org apache catalina loader, this something component, and then this object id has been given. This occupies 10.13% of bytes. The memory is embedded in class loader component. Okay, so we know that this class loader is already required for our application to function, right? So there is nothing that we can do about this. Okay, so you see the detailed information for this objects. If you want, you can just copy this address of this object and search in the heap to locate this particular class. Same way, the problem suspect 2, you can see java.lang.class loaded by system class loader occupy 28.03% of bytes, right? So now this particular class is required. Java.lang.class is by default a definition of sorry, I think, oh yeah, I thought that it got disconnected. So by default, it's a definition of class, and it will be required for the Java to work on. So how we can do it over here is, you can just see this total instance name class java.beans.thread group context. Okay, so if I just right click on this and I just click to I try to find out this object where it is, control C, and you can see this find object by address is there. I just click, I just paste this address and I click OK. So now you can see this search has been ended, and you can see this class Java beans thread group, that whatever it was showing in the report, I can find it out now. Now you can see inside the context thread group, it is consuming the maximum heap size 33764, it is approximately 20 MB, right? So you can see, you can drill down it, and you can see this, there is one table weak identity map. Okay, so that's nothing but it's a hash map entry. So it is actually consuming the maximum heap. So you can see here, you just this is the way you do it, analyze. You just go drill down it and try to find out what is the problem causing area. Now we are drilling down it again and coming to the last entity is this table, and you see this different values. Inside the table there are different hash map entries. Okay, you can see this hash map entry using this much size particular hash map. So now this hash map is required to function, right? So we cannot do anything about it, right? So it's just a way of showing that how we can analyze the memory heap dump for the memory leak. This is the way that we should do it. Okay, now again going back to this report. Okay, so now understood that how we are how do we should find it, and how we should go to the analysis, right? Now again sorry Sano.
Yes, yes, yes. I can hear.
Yeah,
And
okay.
it's really explanatory. Yeah.
There are different types of information available in this report. I just Okay, so I've just clicked on this table of contents, and you can see this system overview, Heapdump overview, system properties, thread overview, top consumers. Okay, so different information is available. So we already gone through what is Heapdump overview, system properties, and everything, right? So thread overview is also one section that we already know that whenever we capture a heap dump, it will automatically generate a thread dump, and you can see the thread overview inside this mat also, right? So top consumer, you can see this object overview. So which are the objects which is actually causing the top which are the top consumers. So you can see this Catenna loader parallel, which is the same again listed in your leak suspect report. Then classes overview. So it gives you segregated information for each and every class, each and every object. How many classes how many classes are loaded, how many objects are there inside a class which is having highest memory, everything. Okay, so this is the kind of information is available in heap. So I wanted to show you one more thing, which is comparing your heap dump. Okay, and how do you do it? So there is one button. Once you go this class section, okay, let me just quickly close this welcome screen. So I it's expanded now area. So I just go on this leak suspect report, right?
Yeah, I can hear you. Yeah.
Yeah. So we go to this leak suspect report. Now inside the leak suspect, okay. So this is the heap dump overview, and there is one button where we can yeah. So once you go to this histogram tab, you can see this button is enabled over here compared to another heap dump. Okay, so it is readily available. Now when I click this compared to the heap dump, so before clicking, you just try to observe what is the object size, what is the shallow, and what is the retain heap size, because this comparing will be actually at the class level or at the object level. Okay, so you will not be able to get that how many classes are new in this heap dump and all these things, but it will be at the similar class level. So it will apple to apple comparison will be performed by this tool. So just now when I click this compare to heap, so no other heap dump opened in editor. Okay, so you just have to open another heap name. Okay, open heap dump. I have already captured it, so this is open. Okay, so when this heap dump is open, now it is passing. Okay, so I don't want to, it will automatically generate the leak suspect report. And now inside the histogram tab, now if I click on this uh, button to open compare, so it will automatically show me the another open heap dump. I'll just click OK. Okay, now you can see it has generated few of the numbers. Now its objects and shallow size, it is showing plus something, right? So plus 1202 plus 48040. What is this meaning is that the second heap dump that we have taken, it is having 1202 classes extra of this particular reference, soft reference. So these byte classes, 11 objects are extra, 1202 objects are extra, 104 objects are extra in that heap. Okay, same way if you do this comparison in the another the second heap dump. Okay, I'll just click open the second heap dump and histogram. Okay, now if I compare this heap dump with the previous heap dump, okay, it should show me in the minuses. Okay, so again it is showing that how many classes are extra in this heap dump. Now you can see there is zero. Most of the classes you can see this is zero. That means there are no extra classes, because this is the latest heap dump which is expected to have more classes, because application is running for more time compared to the previous heap dump. So in the first heap dump, you can see these are the multiple classes which are loaded. So now the reason for this is that whenever you take a heap dump, you cannot actually replicate the object, and you cannot actually replicate or compare the method and the same object, because the object addresses will be different for every time you take a heap dump, right? So you cannot compare that with the another heap dump at the same in the similar fashion, but you can at least compare that how many objects are there total for that particular instance which are being generated, right? So this is the way you identify that how many extra objects are getting generated. Okay, so this is basic thing that I mean this is the guiding path. This is how where you should start looking at your heap dump and where you should start analyzing your heap dump. Okay, so first thing is done. Now once you open a heap dump again at the overview page, you can see there are different buttons available this at the top. Out of that, the same button, the run expert system test, is nothing but it's running the same leak suspect and all this, right? So leak suspect, top components, and report and run report. So it will give you an entire report of your heap dump, whatever is there inside the heap dump, what are the objects causing maximum size, and whatever the objects are retaining high sizes. And in the similar fashion, you have this query browser, object query browser. So it's okay to use this browser for smaller heap dumps where you have less than some within a gigabyte size. Okay, but if your heap dump sizes goes for the production applications, the heap dump sizes are in gigabytes, right? So for that case, it is not advisable to use this object query language or this object query browser, because it takes a lot of time to parse that query and find out that object, throughout entire this gigabytes of memory space. So it's better to use the visual method other than this object query language. Okay, so this is how you do it with Eclipse memory analyzer. Okay, now another thing I want you to show is the heap hero thing, heap hero, and how how that tool will give you the report. But before that, let's just quickly see that how we can do the same thing on the command prompt. Okay, so it may happen sometime that you may not have access to either JVisual VM, or you may not be able to download any other tool like this mat analyzer. So in that case, how will you get the information that you need, right? So let's just open a command prompt over here. Okay, I will just click JPS to find out which are the Java processes running. So you can see that there are 3-4 Java processes running. So one is Bootstrap, second is sorry, main, and JPS. So first is what we are interested in, right? 27296. This is the PID of our application. We can confirm it with our JVM, right? You can see at the left side of in the JVisual VM 27296. That is the PID. Now, what we want to do is we want to do a JHat. So you just enter the JHat plain command, and you will see the arguments for that. Okay. So before this, we already taken a heap dump. So we just need to use this command jhat with and append it with the file read. Okay. So, but before that, we can also include the different options. Okay, so turn off the tracking object, or turn off the object references to another object. So this type of is available. Okay, so without wasting time, I'll just put jhat, and you just have to give the path of the heap dump file. Okay, so I've stored that file over here, right? Hprof. See. So it is actually, you can see this there are different types of generated files are generated. So out of that, you need to select this with ending with extension hprof, copy it, paste it .hpr, and you just enter it. Okay, so you can see it is reading from this file, and oh, it is saying failed to. Okay, so there are some warnings have been given. So you can see this server is ready and started HTTP server on port 7000. So that means you can access this heap dump at your local host 7000 port. So if I just click local host and I just give port number 7000, so I should see something. Yeah, you can see this is nothing but the jhat. Okay, so jhat running. So it is the plain information of your heap dump. Okay, all classes excluding the platform. You see this package array and all this is listed, all the classes excluding the platform. So this is a very raw information. Okay, so when you are totally helpless and you cannot see anything or you cannot do anything, which will be rarely happen, because today nowadays we have very much tools available, like different APMs are available, different types of tools are available. But at the, it's one worst case scenario, you can use this jhat and it will automatically open your this web browser and you see this list of classes. So I mean, if you go through each and every class, it is very time consuming. That's why we use the different tools like mat analyzer and different types of tools. Okay, so idea behind showing you that showing you this option is that at least you should be aware of that this is something is also available that we can use. Okay, so now just go back to this command prompt and you can see that there are multiple options available with jhat. So you can use -j flag to pass directly to the runtime system. Okay, for example, if you use -j and mx512 to use maximum MIP size of 512 MB, turn off tracking object allocation -stack false. So it will actually track the object whenever you are opening the file. It will track this object back to the memory reference. Okay, so if you don't want to do that and if you don't want to see this warnings, you can use this flag -stack false and -reference. Okay, you can also change the port number of HTTP servers. If anything is running on your port number 7000, you want to change this and you can use this by using this particular flag. Okay, okay, so that's all for this using for command prompt. Let's just quickly show. I will just quickly show with the heap hero. Okay, heap hero. So this is something, a new tool, or we can say this an online available, which can access your heap dump and which can give you a good information about the analyzing your heap dump. So it is saying that before uploading a file, you should compress it. Okay, for quick results, compress in .zip or .gzip format and upload a heap dump. So we'll just quickly go inside this and we'll just quickly try to zip it, because compression works very well with memory files. You can see this when you compress it, it's only 9 MB and the actual size is 32 MB of that heap. Okay, so now I'll just click on choose file, go to the directory. You can see this is the file, open, and I'll just click on analyze. So it will take some time to analyze. So because it's compressed format, now it will first decompress and do everything and it will run your its over algorithm. Okay, so the idea of showing you this tool is that because whenever you do a heap dump analysis, for that also you need a tremendous memory requirement. Okay, because opening on a memory dump in another system also requires some high end configurations, right? So if you don't have this kind of system available with you, or if you don't have information or highest capable machines with you, you can use these tools, because these heap hero, they have their own servers running. So you just have to upload your heap dump so that all the analysis part will be will be done at their end, heap hero end. Okay, so again, one thing is that it's totally third party, right? So you don't want to directly upload your heap dump to another third party tool without taking consent of your organization and your security protocols, considering your security protocols or whatever the things that that is been implemented in your project or in your company. So you need to consult your proper resources first before doing this kind of thing, because it may lead to your some consequent security actions against you if you do this without telling anyone. Okay, another way that you can use this heap hero is that this is available in API forms. Okay, so you can actually call an API of heap hero to analyze the heap dump. So they have the detailed documentation on their side that how you can implement this heap hero in API format. Okay, so let it just load. So this is the last part of this session that we are going to see, and after that we concluding this session, and the next session we will be discussing about AWR reports and how do we analyze the AWR reports. So for that session we are actually trying to generate one sample application again, and I have already installed the Oracle database. So once I get this sample application and JMeter, so we will load this application and we will see that how we can generate the AWR report and how we can collect it from the Oracle database and what are the different things in that AWR report.
Yes, you can. Thank you so much. I really appreciate it. Although I've not written the script, but I'm gonna go through the record. I really appreciate it.
Okay.
Thank you so much.
Yeah. So I'm just waiting for this. This is Heapdump to get uploaded. There are disturbances from your side, Sarah. Can you please keep on mute? Yeah, thank you. So it's again taking some time. Let me just check if I have another Heapdump that we can do. Okay, so I have one sample Heapdump. Okay, guys, I think it's taking some more time. So what I can do is I'll keep it loaded. I'll get it loaded, and before we start the next session, so just before starting the next session, I will just show you the overview how it looks in that Heap Hero tool. Okay, just open. So this is the small heap dump that I have given. The other one is still processing. Now you can see it's passing. Oh, the site got crashed. Okay, so no ways, I will have it ready for the next session. Next session we'll start. So before we start the next session, I will keep it ready, and we'll see that what are the different types of yeah. Now I think this is open now. You can see this this is nothing but it's an extension of your mat tool, but this is very user friendly, and it also gives you very good level of information of with your for your heap size. Okay, so you can see heap statistics, total size, total object counts, class count, thread counts, everything that you get in the mat, but in much more sophisticated way. You also get the memory vested. You can see 3.92 MB, 34% of memory is vested, and where it is vested, you also get that pie chart. So there are duplicate arrays, there are some duplicate strings, so there are some inefficient collections. Okay, so this is where you this is where it gets right, the inefficient object arrays. So this kind of analysis has been done, so it's a very good tool actually. Then it gives what's in your memory by class. So this same thing that we already have in mat, but in this is represented in some different ways, which is easy to understand. Okay, and you can see, you just scroll it down, you can read it through, and it is very much user friendly to read. And what is the different, what issues, what are the different fixes that you can apply. So these recommendations are also available inside this. Okay, so for the inefficient collections, what you can do, what are the different ways you can implement your arrays, and what are the strings that has been used. So in that case, you need the source code. Obviously, if we don't have access to source code, we can at least give this as a feedback, or as a recommendation to our developers, that boss, this is the area, this is the class which is showing the duplicate classes in the heap dump. So can you please, rearrange this or something, try coding it efficiently. Okay, so this is the way you get. So please try out this tool. I won't advise you do it on your production applications. Just try the sample application that we are using, right? The JPage store, use that applications Heapdump to understand how, what are the different things available in this, right? Because I don't want you to have any issues in your application or in your of company if you use this tool for the uh, applications or the company are working in. Okay, so this is for today's session, guys. So next session we will look for the AWR reports, and how do we generate the AWR reports, ADDM reports, and how do we analyze it. Okay, so that thing we will check in the next session. So this is for now. Completing today's session. So if you have any questions or queries for this particular session, please post it through the email, or you can send it to the WhatsApp query. I will always try to answer it. Okay, Sanum, bye bye for now. So I'm just signing off, and see you on the next session.
All right. Thank you so much, Shukran. Thank you. Bye bye.
Bye.